So first of all, I wanted to thank everybody for taking time out of their day to view this webinar. We've had some very good feedback from it. I can definitely tell you that a lot of Howard's information is very data heavy, and many people that I've had communication with, watching it once, you definitely don't get all of the information that's being relayed. So people have actually signed up and watched it multiple times to be able to glean more and more information about this very important topic. For those of you who don't know me, my name is Jason Spangler. I'm the flooring division manager here at Wagner. I'm responsible for not only the rapid RH or concrete moisture testing side of the business, I'm also responsible for the wood flooring side, dealing with our small hand meters for testing moisture in finished wood products and wood subfloors. We're going to go through a very brief Q&A time. Definitely, if you have any questions, please email them to us. If for some reason I am not able to get to everybody's, I'll definitely respond to you one-off via email. On the other side, if you do have questions that come up, please don't hesitate to get a hold of me directly. My phone number is 800-634-9961, and my direct extension is 235. So without any further ado, looks like we have a question from Chris. He wants to know if we're going to give some kind of target RH readings for concrete moisture testing. I can give you very broad ranges, but the reason why we don't give them to you is because those numbers actually come from the manufacturers of the flooring and or adhesive. What I can tell you is, if you look in a manufacturer's guidelines, at least all of the ones that I have looked at, you could have some smaller companies that don't have it in there, but the companies will typically have it in their heading of subfloor preparation. So it's typically on the very front end of their installation guidelines. And you can identify it based off the fact that they reference ASTM F2170, or they reference concrete moisture testing and relative humidity percentages. I can tell you that we have a free app that you can download for a smart device that's called RH Spec, or you can look at it online at rhspec.com. And it has definitely not all manufacturers, but it has a lot of manufacturers, and it has direct links to their installation guidelines so that you can see where that information is referenced. Now, from a very broad standpoint, usually I think the lowest that I've seen required is about 75% relative humidity. And on the high end, about the highest that I've seen without some type of remedial product is about 95%. So usually what you're looking at is a direct glue down wood. If you look at NWFA guidelines, a direct glue down wood to concrete, you're looking at about 75% or less. That's what their specifications are. If you look at vinyl, rubbers, solid sheet products, depending on the products, 80 to 85. And again, I'm not saying this is absolute. These are just some general ideas. 80 to 85%. Some products are going to be a little lower. Some may be higher. So always reference the manufacturer's guidelines. And then you're typically going to see the VCTs in the 85, 90, some of them up into the, higher than that, depending. The carpet tiles, I've seen them range depending on the types of adhesive or we'll say, installation products that you use on them. I've seen them go up, above 90%, but you have some of them that are definitely, if you're just using an adhesive product to put them to the concrete, sometimes they're in the 75 to 80 ballpark. So most of it deals with the permeability of the product, and it deals with a lot of it, the experience and or testing they've done on their products to find out what they can withstand from a moisture standpoint. Looks like when I look at the next question I have from Nick, it says, what is the life of the smart reader once installed in the concrete? The smart reader, when you look at it, comes with a 2-year NIST traceable certificate of calibration. When it's put into the hole, as long as it's within the parameters of that 2-year certificate date. It'll either be a 2-year certificate date, or it'll give you a date that it was calibrated, and the certificate is good for 2 years from that date. That's what you're looking at as far as the life of the smart reader once it's installed. Now, that being said, you always want to, if you put a sensor into an environment that we know is, non-controlled, the concrete is, 98+% relative humidity, because in today's construction schedules, we're always testing or trying to move things faster than what the concrete usually will allow. You always want to have some kind of verification of those initial sensors that you put in. So we always recommend, when you're going into environments like that you do sampling to start with, and then you build your overall volume or number of sensors on that job up to a point so that you can compare all the information back and forth. Definitely is something where, when you look at the sensors, using them for a duration of time is definitely something that's done on a consistent basis on a lot of different projects. Another question I have deals with the thickness of slabs. How do you know how thick a slab on grade is? Well, there's a couple ways. One is that they do make an instrument that will actually work off of an echo impact principle, where it will actually send a signal through the concrete and then come back to itself to give you the thickness. You scan it across the surface of the concrete, shows up on a smart device, iPad, iPhone, that nature. Great concept. Still kind of spendy for most people. I think the last time I checked, they were about $2,500 to do that. So then we look at what a lot of people do. They look at construction documents. They look at if they're doing rehab jobs. They look at if there's any kind of plumbing alterations that are being done, if there's trenches, identify the thickness when the trench is open. I usually tell people that when you get to the mindset where you have to know what the thickness of the concrete is, you'd be surprised at how often you can actually see it and how many signs there are on the job site. Excuse me. Elevated slabs, you're going to have penetrations through the pan decking. You're going to have penetrations through the floor. You typically can see stuff there. What I will say is that with all those things being thrown out, I find that there are people out there that will drill smaller diameter holes in a couple of different spots on a slab and take a piece of pliable wire and make kind of a J-hook out of it and push it down through the hole until that J pops out the bottom, and then you can pull it up until there's resistance. Mark it off with a Sharpie, pull it up. You can see where the radius is on the J, compare that to the Sharpie mark, and get a pretty good idea of what the thickness is. Again, that's last resort, but there are people out there that do that. Again, not saying they turn the slabs into Swiss cheese. They're just doing a couple of different spots in strategic locations to be able to get a couple of things to reference. Another question I get revolves around pan decking. When you have highs and lows, or deep spots and shallow spots of concrete, how do you know where to drill? Well, the first thing is, I still hear there's a lot of misconceptions about whether or not a vented pan deck is drawing from one side or drawing from two sides. And it definitely is drawing from one side, which means that you're going to go into whatever that thickness is. You're going to go into that slab 40% of whatever 40% of whatever the thickness is that you've determined. First thing is, when I say what is the question is, what is that thickness? The ASTM standard at this point is totally silent on the question that I'm throwing out, or the question that's posed to me. That being said, there's a couple of ways it's being done out there. One is, you can identify where the deep sections of the concrete are. One way to do that is with a very inexpensive metal detector. It actually looks a lot like a stud finder that you would use on a wood on a wall to identify wood studs. And it's got a signal that is strong enough that it will pick up the hi-hats on the metal. So as you scan it across, it'll pick up the hi-hats, but it won't be so strong that it picks up the deep sections. And so you take it and put it on the floor. scan across, get one hi-hat, scan across, get the other hi-hat, mark them both, and then drill in the middle. In that situation, you're going to be looking at doing 40% of what the maximum thickness is in the deep section. One thing that the ASTM committee is looking at right now to hopefully get something on the books to make it so there's more guidance in doing this is they're potentially looking at coming up with some kind of effective thickness calculation that makes a determination between the shallow and the thick, blending them, and then taking a percentage of that total and drilling anywhere on the floor. So, you know, again, I can tell you that that process or that methodology is being done in one way, shape, or form by some people out in the field already, but it's not on the books yet. Another question from Nick. How about testing on pre-stressed concrete? So when you start looking at some different types of flooring builds, if you will, if we start looking at planked flooring, if we start looking at precast, and I know that obviously the question was pre-stressed, but we start looking at precast with some type of thin overlay topping on it, which is typically the case. You start looking at some of the post-tension products that are out there where you have cabling running through it. So we start looking at the planks, the precast. Most people will tell you that on a precast situation, again, ASTM standards totally silent on these different types of systems specifically. They talk in general terms on as far as the science behind concrete drying. On the precast, most people will tell you that those precast planks are baked down to a point where moisture content in them should be negligible. Now, again, there's no way to be absolute about that because they could be set up, they could be in weather, they could have issues. But most people that are out there, what I hear them doing is they are more concerned about whatever the overlay is on the top of the precast, because that obviously is poured monolithically at after the fact. Typically, you're looking at them going at a 40% thickness of whatever that overall thickness of that overlay is. And again, it's just what I'm hearing people are doing out there in the field. You start looking at any kind of elevated slabs that you're dealing with post-tension. I always tell people, again, you need to have an expert. It needs to be something where you're very, very, very cautious about it. Cabling in there obviously can kill people if you do penetrate or have some kind of perforation of the cables. We definitely need to be very, very careful of that. There are devices like ground penetrating radar that you can use to identify the cabling. Sometimes they use, and they have people that actually can identify it pre-installation, people that have been on the job the entire time, things of that nature. So definitely something you want to be cautious about. But that being said, I can tell you that post-tension stuff, there's people that are installing sensors all the time. So it looks like those are all the questions that I have. Again, if we have any questions specifically that arise after the fact, please don't hesitate to give me a call. Again, my name is Jason Spangler. Phone number is 800-634-9961, and it's extension 235. Thanks, and have a great day.